Now that we've looked at where a function is increasing or decreasing, that also will tell us where the highs and the lows of the graph are, and that's something that's called relative extrema. At the end of this lesson, you'll be able to find the relative extrema of a function by using the first derivative test. All right, a relative extrema, again, it's an extreme point. Notice it says relative this time instead of absolute. They are the hills and valleys of the graph. Hill and valley points of a graph, high or low points also. Basically, the difference between relative and absolute. Absolute are you're given a certain interval, and those are the highest and the lowest. The relative are just if I've got a graph that looks like this, especially if there's arrows on it, they just be like the in-between hills and valleys. And we've already found some of these, but this is just a little bit different because you're not given a certain interval that you have to find it on. So what we're basically going to do is, again, use the first derivative test, and you'll notice when we're using this, we've actually already found the relative extrema without actually knowing that we found it. If f prime changes from a negative to a positive, the critical point will be called a minimum. If the f of x changes from positive to negative, the critical point will be a maximum. So let's go ahead and look at the examples. Okay, you'll notice actually this example came from the previous PowerPoint. You'll notice that we were looking for increasing and decreasing, and I was looking for the derivative, and I'm just going to stick with this derivative chart right here. Okay, and then let's just think about this. We knew when the derivative was positive, the function was increasing, so the function was going up, and then after 3, the derivative was going down. So based on that, is that point a maximum or a minimum? Well, you can tell it reaches a maximum and then it comes back down. So if it's asking me for relative extrema, I can say I have a relative max at x equals 3 because it goes up and then goes back down. I don't have any minimums because the graph never goes down and then goes back up. Okay, if I'm looking at number 2, again, I'm just going to basically look at my chart right here. Notice the function's going down and then it's still going down. So the function never comes back up. So there actually are no relative extrema on this specific example. There are no high or low points, right? If I look at the next one, again, basically we can just look at the f prime chart that we already did. I know based on this chart that the function is going to go up, and then the negative is going to make it go down, and then since it's positive, it'll go back up again. So based on this, at negative 2, since the function went up and then it went back down, I know that x equals 2, there is a relative max there. So I'm going to put relative max at x equals negative 2. And the next thing that we always want to do, and I forgot to do that on number 1, is we want to write a because statement to justify our answers. So why did I decide that this was a max? I decided it was a max because f prime changed from positive to negative. Okay, and then I noticed since the function went down and then back up at x equals 2, there was a relative min. So there's a relative min at x equals positive 2, and again, we're going to always justify it's because f prime changed from negative to positive. So that's how we'll always justify our answers. If we went back up here, the relative max occurred at x equals 3 because f prime changed from positive to negative. Okay, and if I had to justify my answer on this one, there are no relative extrema, basically just because f prime doesn't even change signs, so does not change signs. Alrighty, now let's look at those next couple examples that we kind of already did. Okay, example number 4, it asks us to now find the relative extrema. We've already found our chart from the previous example. So if you think about it, since my derivative goes from positive to a negative, that means my function's going up and then going back down, and then here it's going down and then it goes back up. So I can now say that there is a relative max at x equals 0, and why is it a relative max? It's because, it's because f prime changes from positive to negative, and then there is a relative min occurring at x equals 1, and that's because f prime changes from negative to positive. Okay, let's look at that last example. Again, we found in the previous video, we found where the function was increasing and decreasing, and we looked at this f prime chart, so we're still going to use this f prime chart. We found that f is just always decreasing, and since f is just always decreasing, there is not going to be a min or a max. So again, I'm going to say there are no relative extrema. And if I use my derivative chart to explain it, it's basically because f prime does not change sign. It never goes from positive to negative or negative to positive. So we'll just put f prime does not change sign. Notice on each of these I was always referring to my f prime chart, and that will get me through any problem that I need to. So hopefully now you can find the relative extrema of a function.